Alright, so let's take out this little motion problem right here. And notice specifically we're going to be doing a motion in the same direction now. Example 2 was motion going in opposite direction. And so now I'm going to model for you how do you work these kind of problems out that are going in the same direction. Alright, so let's check out this guy right here. So we have Tremaine, who took 3.6 hours to drive to her mother's house on Saturday morning for a weekend visit, but then on a return trip, she had a little traffic, you know, bumper to bumper, and so that trip took 4 hours, so it's a little slower there, and her average rate on Sunday was 5 miles per hour slower than on Saturday. What was her average rate on Sunday? Craziness here. So just so we have a little visual here, we know we're going to use distance equals rate multiplied by time. That's all very common for these motion problems here. But if she started right here at bing, and now she's at Grandma's house. Hey, Grandma. Hi, Shani. And then she went back. So just by looking at the distances, is one thing that you have to notice here is that when you have motion in the same direction, one thing that you want to notice is that their distances are the same. The distance from going from home to Grandma and from Grandma to home is the same. So we're going to use that as part of our equation when we start putting this all together. Okay, so let's go ahead and put together a little chart here. It's always helpful to have that. So I'm going to go and set that up real quick. Okay, and distance equals rates multiplied by time. And again, we know that the distances are going to be the same. D equals D. So we'll fill that in as we go. All right, so let's take a look here. Going to Grandma's house, 3.6 hours to drive to her mother's house. Oh, sorry, not Grandma's. We're going to Mom's house right here. Jermaine's probably an adult or something. Who knows? So on the way up, and so like I'm going to call this right here Saturday, and this right here is going to be Sunday. Okay. So driving to her mother's house, it took her 3.6 hours. So I'm going to put 3.6 hours right here. And actually, that should go under time, not the rate. So 3.6. Now on her way back, and it took her 4 hours, so that means going Sunday. On her way back, her time's going to be 4 hours. Now watch this. It's a little tricky right here. A little bit of a trickly. Her average rate on Sunday, so talking about Sunday right here, her average rate on Sunday was 5 miles per hour slower than on Saturday. So her Sunday was 5 miles an hour slower than Saturday. But watch this though. I'm not going to put anything down yet. Let me just read the question now. What was her average rate on Sunday? Very common in all these algebra problems, pretty nerdy. Whatever you don't know, that's what your variable is. If you don't know, or whatever the question is, like, hey, what is the value of this? I mean, make that your variable. So really, when it says what was her average rate on Sunday, so here's Sunday, here's rate, I'm going to put an R right there. That's my R. I'm going to let R be my average rate on Sunday, because that's what I'm trying to solve for. I'm trying to solve for R. So now let's come back to this guy right here now, this statement, and let's see if we can make some sense of this. So now, her average rate on Sunday, so we're still talking about Sunday, was 5 miles per hour slower than on Saturday. So her rates when she traveled on Sunday is 5 miles an hour slower than on Saturday. So that must mean that if this is R, if her rate on Sunday was R, then her rate on Saturday must have been 5 miles an hour slower or faster? Well, faster. So it has to be R plus 5. Okay? Her average rate on Sunday, okay, we're talking about this right here, was 5 miles per hour slower than on Saturday. So if this was 5, then this is 10. 10 minus 5 is going to give us 5 right here. If this was 3, then this must be 8. Because if I have 8 and then if I subtract 5, then I get 3 right here. So this fits. The common error is this, is that normally students want to make this R minus 5. Put r minus 5 and then make this r. That sounds nice, but what happens is that when you get your answer, you're going to be off. And the reason for that is you need to let your variable, check this out now, let the variable be equal to what you don't know or what you're trying to find. That's the trick, is this. What's her average rate on Sunday? That's going to be your variable. And then go ahead and then modify the other rate. Okay, so like I said, this distance on Saturday is the same as the distance on Sunday, right? Distance traveling on Saturday is the same as the distance traveling on Sunday. They're the same thing. So if these two d's are equivalent, then that means these two are equivalent. Let's see if you get that there. If d1 equals d2, then I call this d1 and d2. Well, what is d1? Oh, d1 is r plus 5 times 3.6. So I'm going to substitute d1 for 3.6 times r plus 5. And what is d2? Oh, well, d2 is r times 4, or 4r, so this is 4r. And now we have our setup. Okay, notice how this is set up. If you are doing a motion problem when the motion is in the same direction, you're always going to have d1 equals d2. Okay? And you're always going to set those distances equal to each other. And if you have, I'm just going to go back to our last problem. If you have motion in the opposite direction, then you're always going to add the two distances, like I did right here. d1 plus d2 equals the total distance. So that's really the distinct difference between how you set up these motion problems here. All right, so we're just going to go ahead and solve these guys here. So I'm just going to go ahead and do the distributive property. So I get 3.6r plus 18 equals 4r. I'm going to go ahead and throw this guy over here. So subtract 3.6r, and I get 18 equals 0.4r, divide by 0.4, divide by 0.4. So r is going to be 45. Well, 45 what? What was her average rate on Sunday? And we're traveling in miles per hour. So it's 45 miles per hour. That's how fast she's traveling on Sunday. Sunday is r, so that's exactly what we were trying to find.